All right, so this video is going to cover the APCSP loops chapter practice quiz number 2. So these are kind of what your questions look like. So let's get started on these. So it says, in the procedure mystery written below, the parameter number is a positive integer greater than 2. So which of the following will be the result of running the mystery procedure? Well, I'll show you how to do this in table form, but what is this doing? Each time you repeat, you're adding 1 to it. So it's going to repeat 4 times. So you're going to add, whatever it is, 4 plus your number, whatever it is. Because number doesn't change, so number would be whatever it is. So number plus 4. So it's definitely B. So you can reason through this, but let's just do this. Let's say number is 2. And that's what it starts off as. And we'll say, I don't know, repeat. There's my repeat 4 times. So it will be the first time we do that, then we do the second, third, and then 4th time we'll repeat it. And then what do we got? Number... So repeat this 4 times, so we got 2 plus 1 is 3. Second time through, we repeat, we got 3 plus 1 is 4. Next time around, we got 4 plus 1 is 5. 5th time through, we got 5 plus 1 is 6. So our original number was 4. 4 plus 2 is 6. Now, yeah, there could be another way that you could think about this that might get you screwed up. At least in my head, I'm thinking about this before it solves. Because if you actually did 6 plus 4, you would get 10. That's definitely not how you want to think about that. Yeah, I guess this is the only way I would think about it. Have your original number plus 4. And that's how I do this. So 1 is B. Okay. 2. Let's open this up. Consider the following program, which is intended to print the sum of all the positive integers to number. So sum is 0, so I'll write that down. Sum is 0. Then we've got repeat number. So again, I guess we just pick which of the following best describes? I'm going to just pick a number. I'll just say repeat 3 times, let's say. So let's say number is 3. Okay. And number never changes here, so that's fine. And then what do we got? We've got sum is set to sum plus number. Okay, so what do we got? 0 plus 3 is 3. So sum is 3. Number is still 3. And this is going to be 3 times. So then we've got what? 3 plus 3 set to 6. So then we got what? 6 plus 3 is 9. So sum is now 9. And we did this 1, 2, 3 times. So it says repeat whatever times it is. So we repeated that 1, 2, 3. And so our final value was 9. Consider the following, which is intended to print the sum of all the integer values. So the sum of all the integer values 1 to 3 would be 1 plus 2 plus 3, which would give us 6. And so it does not work. This one gives us 9. The program correctly displays, nope. The program does not work as intended, but rather it displays the number squared. So 3 to the second power is 9. Okay, so that actually works because 9 and 9 are the same. The program does not work as intended, but rather displays the factorials. 3 times 2 times 1 is 6, so that's not right. And then the program does not work as intended because sum should be initialized to 1. Yeah, that doesn't. So anyway, your answer is 2. Or your answer is B for 2. So 3. Says consider the following program, which is intended to print the count of even numbers between 1 and num. All right, so we've got count. We've got I. We've got I modulus 2 equals 0. Then we got what? Count is set to count plus 1. Then we got I is set to I plus 1. All right, so however many times, I don't know. Either way, this is 0, this is 0, 0 mod 2. That is 0, because remember with modulus, the left-hand side is less than the right-hand side, so that's 0. So that's true. And because it's true, we run this. So, actually, what does it say? It's an even number between 1 and number. 1 and number, so we don't start at 0. So, screwed that up. Count is 1. Count is 0. I is 1. 1 mod 2. And that is not equal to 0. 1 modulus 2. The left-hand side 1 is less than the right-hand side, so this is 1. So we don't run this one this time, and we run what? 1 plus 1 is 2. So I is 2. Count is still 0. So 2 mod 2. How many times does 2 go into 2? 1 time with the remainder of 0. So then we do this count. We do 0 plus 1 is set to, so count is now 1. And then we do this. So we got 2 plus 1 is 3. That's not true. 2 goes into 3 1 time with the remainder 1, so we skip this one. And what do? We do 3 plus 1 is 4. Okay, so I becomes 4. And this whole time count is 0, and it's 1 right here. So 4 mod 2 is equal to 0. How many times does 2 go into 4? It goes in 2 with the remainder 0. So we run this count right here. So count is now 1 plus 1, and that is 2. So count is 2. And what do we got? 4 plus 1, and that is 5. So basically what it's doing is it's counting if these are even numbers, basically count. Okay, so we counted 1 here, and that's there. We counted another one, so that makes that 2 there. So it is intended to print the count of even numbers between 1 and number. So I could keep going with this, but the program correctly displays the count of even numbers between 1 and number. So it works. All right, it says in the procedure mystery written below, the parameter number is a positive integer greater than 1. Repeat until which of the following best describes the result of running the mystery? So repeat until the number is greater than 100. Okay. So what is it going to do? It will add all of. Well, no, it's not adding. Whoops, that's multiplying. Make sure you see that. I saw adding at first, but that's multiplying. It's taking your number and multiplying it by itself until it's greater than 100, and then this repeat's done. And then it comes in here and says, if the number is 100, return true, else return false. Which of the following best describes the result? The procedure returns true when the initial value of number is less than 100, and otherwise it returns false. So I guess we gotta check and see what, some numbers to test, see what's going on here. Okay. Number is greater than or equal to 100. Repeat that until, and then what do we got? We got number equals 100. If that's true, return true, else return false. Okay, so let's say, I don't know, let's say 8. So again, here 8 times 8. So 8, repeat until 8 is greater. So is 8 greater than 100? No. So we do 8 times 8. 8 times 8 is 64. So we go back up. Number 64. Is 64 greater than or equal to 100? Nope. So we do 64 times 64, which is, I don't know, but it's a lot greater than 100. Is it equal to 100? No. So they return false. So in this case, the procedure returns true when the initial value was 8, and in this case it returned a false here, because whatever this is, 64 times 64 is not 100, so that would return false. So yeah, no, A doesn't work. B, the procedure returns true when the initial value of number is 10, and otherwise, so 10 is less than 100, so 10 times 10 is 100. That works. C, the procedure returns true when the initial value of number is 100, and otherwise until it's 100 or equal to, so that it wouldn't even run it, and then it would be, so C works. Okay, so D is the most correct answer, even though B and C are correct. So this is the most correct because that and that 10 or 100 will return true. So these are actually false because B didn't account for 100 and C didn't account for 10. Okay, so both 10 and 100 work for 4. Okay. So I just didn't get far enough wrong to think about, the so 5. The procedure mystery written below, the parameter number is a positive number. Okay. Which of the following best describes the result of running the mystery? Alright, so let's say we've got a number. Okay, we got a number. And let's just say number is 3. Repeat into number is 1. So result initially is 1. So we're going to repeat this down. So then we got result is set to, I'm going to run out of room. Result times number. And then we just subtract 1. So is 3 right here, number equal to 1, repeat until it's equal to 1. So it's going to go through it. So it does what? 1 times 3, and that sets that to 3. So the result is now 3, and we subtract 1 out right here. I didn't have enough room, but number is what? 3 minus 1 is 2. Okay. So then is repeat until the number is 1. 2 is not 1, so then we get in here and we do result, which is 3 times the number of 2, and we get 6, and we subtract 1, and number becomes 1, and result is, sorry I didn't put result over here, but result is 6. Okay, so then we're done and returns result, which is 6. Which of the following best describes? So if the initial value of number is 1, the procedure never begins. That's false. If it's 1, it doesn't redo this part, but then it just does that. So it just doesn't repeat, but so that's not true. It just says result is 1, and it returns a result if number is 1. B, the return value will always be greater than the initial value of number. The return value, what's being returned, will... Okay, the return value will always be greater than the initial value of number. So, let me think about B for a minute. Okay, so the number is a positive number, so the return value will be a positive number greater than or equal to the initial value. Return value will be a positive greater than or equal to the initial value. So this is what's returned. The return value will be greater than or equal to. So let's say numbers, so this won't work, B won't work because let's say number is 1, result is 1, so return. The return value will always be greater than the initial value of number. So that would prove it to be false. The return value will be a positive integer greater than or equal to, because again, I just proved it wrong. If number is 1, it's equal to result, which was 1 right here. So this is false right here. That's true. Will be a prime number greater than or equal to, well, 6 is not a prime number. A prime number is 1 in itself, not including 1. So 2 is a prime number, 3 is a prime number, 5, 7, 11, 13. Okay, 6 is returned, and that's not a prime number, so let's see. All right, 6. Consider the following code segment. All right, so let's set for which so values of x will the loop 1 and 2 have the same output. All right, so let's do this. We'll say n and x and y and s dot o dot p x. And then let's say we have p is less than n, y, s dot o dot p, y. So n is 10. Let's set x to 7, which means y is 7. So then is 7 less than 10? Yes. So we add 1 to x, which makes it 8, and we do, we print 8. Okay. And n is still 10. Y is still 7 throughout this whole thing, it looks like. So then is 8 less than 10? Yes. So, you got your 8, 9. That becomes 9. That was 10, and that's 7. 9 is less than 10, so we add 1 makes it 10. So it does 8, 9, and 10. So then is 10 less than 10? No. So this would be what it prints out, 8, 9, and 10. And for this one, y would be what? Whatever x is, so that's 7. And then we do 7 less than 10. 7 is less than 10, so then we do y would be originally a 7, so then it would be 8 because we added up right here. Then we print 8, and then we add 1 to p. P becomes 8. 8 is less than 10, so we add 1, becomes 9. We got our 8 and our 9 printing. We add 1 to p, which becomes 9. 9 is less than 10. We add 1 to y right here, so that becomes 10. So that's where we got 8, 9, and 10. We add 1 to p, it becomes 10. Is 10 less than 10? No, that's not true. So it looks like they're doing the same thing. All values are the same. And I feel like I've done this one more than a few times. So write a method called alarm that prints the string alarm multiple times on separate lines. The method should accept an integer parameter that specifies how many times the string is printed. Print an error message if the parameter is less than 1. Okay, so public void alarm int times. So if times is less than 1, we do an error s.o.p. Else, we got ourselves a for loop. Int I equals 0. I is less than times. s.o.p alarm. All right, so this is done.